Alright guys, so we're going to be quickly running through the graded work questions that were given to you yesterday. So the first question says, is a matrix with element 3 scalar? Now, let me put this to the side here. Now in answering question 1, alright, so these are the solutions. Alright, so to question 1, you're asked, is the matrix with element 3 in its scalar? The answer to that question is yes, because the matrix has only one element in it, and when a matrix has only one element like this, then you really don't need to write it as a matrix. So if the matrix has one element present, and this element is 3, then really and truly you can write that without the brackets because it's only 3. So the answer to that is yes. Alright, the matrix is in fact scalar. That will be the answer to question 1. Alright, question 2, it says write an example of a matrix of the order. So number 1, you're asked to write a matrix of the order 1 by 4, which means you have 1 row and 4 column. And the answer to that would have simply been, it's 1 row, so we'd have 2, 3, 5 and a half for argument's sake. So you can clearly see that we have 1 row here and 1, 2, 3, 4 columns. So that would have been the answer for part 1 of question 2. Alright, so that would have been the answer there. So we're going to get this out of the way. Alright, so let's take a look at this. Alright, so we're still at question 2. Take this down some more. Alright. Okay. We're still at question 2, part 2. So we want to write a matrix that's of the order 2 by 3, which means we have 2 rows and 3 columns. So this would simply be, it says 2 rows and 3 columns, so 1, 7, 10, minus 2, 0, 8. So you can clearly see here that we have 2 rows and 3 columns. So that would have been the answer to question 2. Now for question 3, so we're going to remove this. We're moving on to the next sheet. Alright, so we're looking at question 3, and question 3 says write the identity matrix. Now the identity matrix would simply be this. And some of these questions we're testing to make sure that you're taking down correct notes and so on, that you're actually honoring your end of the bargain by ensuring that you keep notes. Alright, so the special letter for the identity matrix is I, and the elements will be 1, 0, 0, 1. And they must be in that specific arrangement. So that would have been the answer to question 3. Okay, so moving on to question 4 now. Question 4 says, state whether your example given in question 2 part 1 is a row matrix or a column matrix. So question 2 part 1 would be this. Okay, we should state that whether this matrix is a row matrix or a column matrix. That is what question 4 is saying. And obviously, since it has 1 row, it must be a row matrix. So the answer to question 4 would be a row matrix. So just going to indicate that here. That would have been a row matrix. Alright, so we're progressing. We're moving on to question 5. Now at the end, I'll just display the answers again so you can see it. Moving on to question 5, it says, what condition must be present in order for 2 matrices to be added to or subtracted from each other? So that would be question 5. What condition must be present in order for two matrices to be added to or subtracted from each other? And the condition would be that both matrices must be of the same order. So both matrices must be of the same order for addition. I'm just going to do short for addition or subtraction to occur. Okay, so both matrices must be of the same order for addition or subtraction to occur, and that would have been the answer to question 5. All right, so we're on to question 6 now, so this gets taken out of the way, and we're on to question 6. Now, question 6 says, given matrix A is such and matrix B is such, determine part 1, which is 3A minus 2B. Now that is pretty simple, and if you remember, first of all, I'm just bringing this forward a little bit. The order of this matrix here, it has 3 rows, so it would be, and 2 columns, so it would be 3 by 2. This one is also 3 by 2. So when they're of the same order, addition and subtraction can occur, right? And of course, for part 1, the recommendation is to do this first, do that second, and then do the subtraction. So let's see if we can get that done. Okay, so let me see if I can put this here so we can see clearly, and we can proceed with the solution to question 6 part 1. So question 6 part 1, first of all, 3A means you're multiplying matrix A by 3, and matrix A is 2 minus 7, 5, 3, 1, minus 2. Now, when you multiply all of those elements by 3, you're going to end up with 6 minus 21. 3 times 5 is 15, 3 3 is 9, 3 1 is 3, 3 times minus 2 is minus 6. So 3 2 6, 3 times minus 7 minus 21, 3 times 5 15, 3 3 is 9, 3 1 is 3, and 3 times minus 2 6. And that is essentially what 3A is. Okay? Next thing we need to find is what 2B is. Alright, so 2B means we're multiplying matrix B by 2, and matrix B is minus 1, minus 6, minus 4, 8, minus 1, and 0. So all of those elements will be multiplied by 2. So 2 times minus 1 is negative 2. 2 times minus 6 is minus 12. 2 times minus 4 is minus 8. 2 times 8 is 16. 2 times minus 1 is minus 2, and 2 times 0 is just 0. So that is what 2B is. Okay? So I'm just going to move this out of the way a little bit to complete part 1. So seeing that we have both 3A and 2B, we now need to do the subtraction between both of them. So they're asking us now to find what is 3A minus 2B, and that simply would be, we have 3A here, and that is 6 minus 21, 15, 9, 3 minus 6, and we're subtracting from that 2B, which is minus 2, minus 12, minus 8, 16, minus 2, and 0. So we did a simple subtraction here, and this step is important. So 6 minus negative 2, minus 21 minus negative 12, 15 minus negative 8, and 9 minus 16, and 3 minus negative 2, and negative 6 minus 0. And this, I just injected out the negative numbers here in the second matrix to make sure that you saw things like these. All right, so very, very, very simple. So of course you would have 6 plus 2, a negative sign changes the signs in the bracket, minus 21 plus 12, 15 plus 8, 9 minus 6 is simply 7. We have 3 plus 2. And of course, negative 6 minus 0 is just negative 6. So the final answer, let me see if I can get this done here. Final answer would be 8. Minus 21 plus 12 is negative 9. 15 plus 8 is 23. This is 7. This is 5. And that is negative 6. So the answer would be 8 minus 9, 23, 7, 5, and negative 6. And that would be the answer to question 6, part 1. So let's come back up here. All right, so we're doing a solution now to question 6, part 2. So let's see if we can do this quickly. All right. So we're still at question 6, part 2, where we're asked to simplify A plus B. Now, matrix A is 2, negative 7, 5, 3, 1, negative 2. And we're adding to matrix A, matrix B, which is negative 1, minus 6, minus 4, 8, minus 1, 0. All right, so we're adding the corresponding elements. So this will be simply 2 plus negative 1, negative 7 plus negative 6, 5 plus negative 4, 3 plus 8, 1 plus negative 1, negative 2 plus 0. So 2 plus negative 1 is just 1. Negative 7 plus negative 6 is negative 13. 5 plus negative 4 is 1. 3 plus 8 is 11. 1 plus negative 1 is 0. Negative 2 plus 0 is just negative 2. So that will be the answer to question 6, part 2. So let's get that out of the way. Moving on to question 6, part 3. Question 6 again, part 3. Where we're simply asked to find negative 1/8 b, which means we're doing scalar multiplication here. We're multiplying matrix B by negative 1/8. So it would simply be negative 1/8 times B, and B is negative 1, negative 6, negative 4, 8, negative 1, 0. So these numbers can be written as the number over 1. So this fraction will be negative 1 over 1, negative 6 over 1, and so on. So all of these numbers here represent the numerator. So if this is a fraction, and each of these can be written as a fraction, where these numbers actually would be the numerator, because 8 is the same as 8 over 1. So 8 will be the numerator. So essentially we're multiplying each of these by the negative 1 here. See that the negative 1 is the numerator. And when you multiply fractions, you multiply the numerators, and then you multiply the denominators. And each of these numbers, when written as a fraction, could be written like that. All right, the number over 1. So we just simply multiply the numbers by negative 1, because numerator times numerator gets the job done when you're multiplying fractions. So I had a malfunction of a marker. So this would be negative times a negative number give you a positive, so that's 1 over 8, 6 over 8, 4 over 8, 8, negative 8 over 8, and 1 over 8, and 0. And of course, these fractions can be broken down. So this one here, and of course you should write this, I'm just trying to save some time here. So this one stays as is. This one will be broken down because 2 can go into 6 3 times, 2 can go into 8 4 times, so that would be 3/4. 4 into itself 1, so that would be a half, and 1 1, so that essentially would be negative 1. So these would be the answers you should have broken down to get in the question to move forward. All right, so that should have been the answer. So you should have gotten 1/8, 3/4, a half, negative 1, 1/8, and 0 for question 6, part 3. Now I'm sure I've been trying to go fast enough, but I'm sure that the phone might run out of space soon. So let me see. I think I'm going to need some more time doing this question, so I might have to just stop the video to make sure I don't run out of space, and then come back to this one, because this is going to take maybe in itself about 7 or 8 minutes in terms of explanation. So I'm going to stop the video here and then come back with this solution separate.